Hi, 6th graders. We're on lesson 1-9, Arithmetic Sequences. Our learning target is I can describe the relationships and terms in arithmetic sequences. So a sequence, okay, these are some words that you probably want to write down if you have your tip chart next to you or nearby and you want to take that out and write some examples in there, but you may want this in your notebook as well. So a sequence is an ordered list of numbers. So this is an example of a sequence. You can see an ordered list of numbers. Each number in a sequence is called the term, or a term. So 8 is a term, 11 is a term, 14 is a term, and so on. An arithmetic sequence, each term is found by adding the same number to the previous term. So there's different types of sequences that we'll be talking. Arithmetic, we need to remember, is adding. So you can see, if you look at 8, 11, 14, 17, 20, we can see that we're adding a 3 every single time to get our next number. So each term is found by adding 3 to the previous term. Okay, let's look at another one. Describe the relationship between the terms in the arithmetic sequence 8, 13, 18, 23. Then write the next 3 terms in the sequence. So remember 8, 13, 18, and 23 are our terms. This is our sequence, and it's also arithmetic because we know it's being added by 5 every single time. So as it says, each term is found by adding 5 to the previous term. Continue the pattern, so we want to see what our next 3 terms are going to be. So we add 5. 23 plus 5 is 28. Then we're going to add 5 again to get 33, and then 5 again to get 38. If you want to write that all in a sequence, like we can add that on. So we have 28, 33, and then we can see, yep, 23 to 28 is plus 5, plus 5, plus 5. Okay, describe the relationship between the terms in each arithmetic sequence, then write the next 3 terms in the sequence. So I want you to do A and B, so pause me. I tried to draw a straight line. That does not look like a straight line, but do A and B. So we can see that we are going up by 13 every single term. So we're adding 13. Oops. So our next 3 terms are going to be, so 39 plus 13 is 52, plus 13 would be 65, 65 plus 13 would be 78. Here we can see we are going up by 3, or adding 3 every time. So our next 3 terms would be 16, 19, 21, 22. Duh. It's too late for me to be doing this. 16, 19, 22. Okay, in a sequence, each term has a specific position within the sequence. So let's look at the sequence 2, 4, 6, 8, 10. Okay, remember all these numbers are our terms, and then this is our arithmetic sequence. Specific position. So this number 1, this is our first term or our first position. Second, third, fourth, fifth. Okay, so if we make a table, so I just want you to look at the table. So the position, the first one in position 1, so the first number is 2. We're not even going to look at this middle right now. The second number is 4. So second position, number 4. Third position, number 6. Fourth position is 8. Fifth position is 10. Okay, so as the position number increases by 1, the value of the term increases by 2. So now we can see, well, to get from 1 to 2, we can multiply times 2 to get 2. We could also do 1 plus 1 equals 2. But remember, we have to be doing the exact same thing. So 2 plus 1, because we did 1 plus 1, 2 plus 1 does not equal 4, so we know we need to go back and figure out what our rule is going to be for our sequence. So we know that for every position number, if we multiply by 2, we get the value of the term. Okay, so this is an example of an algebraic expression, or we can write an algebraic expression to represent this sequence. So even though we're adding, or we're going up by 2 every single time, we know that we can keep adding 2, so we already know without even thinking that position 6 is going to be a value of 12. Okay? If this, in this case, if n represents the position in the sequence, the value of the term is 2n. So the problem with this is that if we want to figure out position number 100, well, since we're adding 2 from the previous number, that's a lot of adding. We would have to add 2 plus 2 plus 2 plus 2 plus 2 all the way to 99, and then we could add 2 from that one and get 100. Okay? Or we can also see that because it's being multiplied by 2 every time, we can take the position number, which is n, and multiply it by 2 to get our answer. So if n equals 3, okay, n equals 3, we should be able to plug it in to 2 times 3, and we get 6. Okay? Try it with, go up to position 10, and then try it with, and then extend the table and see what your value of your term is. Okay? And then you can use this equation. So for position number 10, that's our n, so we multiply it by 2, and then we get 20. Okay, so here's another example of a table. So our position, we have 1, 2, 3, and then notice how they put an n. Okay, and then the values are 5, 10, 15. So we can see that we take our position number and multiply by 5 to get our value of the term. So if we wanted to find out the value at position 100, well, we know that it's 5 times whatever number it is, so 5n. So we would go 5 times 100, and it would be 500. So the value of the term would be 500. Okay, if the pattern continues, what algebraic expression can be used to find the number of circles used in the 50th figure? How many circles will be in the 50th figure? So if we look at number 1, I've half filled it in a little bit. If we look at number 1, we know that we can get, or figure 1 has 3 circles. Figure 2 has 6 circles. 1, 2, 3, 4, 5, 6. Figure 3 then, if we keep counting, has 9. So we know that we can take 1, which is our figure number, multiply it by 3, and we get 3. Let's see if it keeps working. Our figure number times 3, and we get 6. Figure number times 3, and we get 9. Figure number x times 3, so we get 3x. Okay, so how many circles will be in the 50th figure? So for any figure x, so if x is 50, our equation is 3x, so we would take 3 times 50, and then we know that it would be 150 circles in the figure. Okay, so any questions, go back and rewatch. Look on your textbook, look online, anything that you need to do to prepare yourself. And have a super evening, and I will see you in school tomorrow. And I almost forgot to tell you to take the 1-9 quiz, although I'm not sure if I have to keep reminding you because I think you know that you just automatically do it after your video. So don't forget 1-9, and now have a good night, and now I'll see you tomorrow.